Hello guys, this is Dave. Today we are going to solve some high level subjective questions, okay? This will be very helpful for your JEE exam where subjective questions are asked, okay? Alright, the first question states a body with zero initial velocity, okay? Just read it carefully, zero initial velocity. So here u is 0, moves down an inclined plane from a height h and then ascends along the same plane with an initial velocity such that it stops at the same height h, okay? In which case is the time of motion longer. Alright, so here are the two situations. This is the first situation and this is the second situation. You see, in the first situation, the object is falling down with a zero initial velocity as mentioned in the question. In the second, let us say it is ascending with initial velocity u1. Alright, so this is a smooth inclined plane, first of all, okay? Smooth inclined plane. So this means there is no friction in this inclined plane, so mu is 0 for both the cases, okay? So what happens is, since this is friction is not there, only conservative force gravity would be acting, okay? And the component of gravity, one component would be balanced by the normal of the inclined plane and the other would take the body downwards. Alright, so this means since conservative force is acting, hence there is energy conservation in this problem, okay? This means in this situation energy is conserved. What is the total energy at this point A? Since velocity is 0, kinetic energy here is 0, only energy is potential energy. What is the final energy here? Final energy would be, let us say this is V. So this would be half mv square plus potential is 0 because height is 0 over here. So mm gets cancelled, V is root 2gh. Okay. Velocity here is root 2gh in this case. Now, in here we see again friction is 0 over here in this second situation. What is happening is that the object is ascending with an initial velocity and is stopping at the same height h. So this means energy again here is conserved. Initial energy would be kinetic, which would be half mu1 square plus 0. Because 0, why? Because we have chosen the ground as reference point. Reference potential is always 0. Okay. This would be equal to mgh. Since body is stopping at height h, so kinetic energy at height h would be 0. So u1 equal to root 2gh. Again we have this. So we see that v equal to u1. Alright. Now what is the time taken? Time taken, first of all, this would be, first of all, here this would be an acceleration. Okay. What would be the acceleration? Acceleration would be g sine theta. Because only force acting here is mg sine theta, which is causing the object's acceleration in this first situation. Mg sine theta can be equal to 2ma, mm gets cancelled and a equal to g sine theta. So what would be a? You see, in the third equation of motion we had v square minus c square equal to 2as, if you remember. So here we can apply this equation. Since v is there, u here is 0. So v square equal to 2as. Alright. Now what would be the time taken? Time taken would be, you see, we can also assume one thing, that v equal to u plus at. This was the first equation of motion, if you remember. U is 0, so v equal to a times t. So t is what? V by a. So what is v? V here was root 2gh, right? So t1 would be equal to root 2gh divided by g sine theta. Alright. Okay, we have t1 over here. Alright. So how about t2? You see, since the object is ascending, deceleration will occur because the component of gravity would be opposite to the velocity. Here acceleration is occurring because component of gravity is along the velocity. Alright. Since deceleration is occurring, you have the equation of deceleration. We have, v equal to u minus at, if you remember. V is 0 because finally the object stops at height h. So u1 equal to at2. What is a? Only force acting is mg sine theta. So the deceleration would be g sine theta. So T2 would be equal to U1 by G sine theta. What is U1? U1 is equal to V. So T1, T2 would be equal to root 2GH upon G sine theta. Hence, both the times are equal. Okay. If friction is not there, both the times are equal and object takes equal time in coming down and going up. Alright. Alright, so let's move on to the next question. It is written a point mass starts moving in a straight line with a constant acceleration a. Okay, just remember acceleration here is constant. At a time t1 after the beginning of motion, the acceleration changes sign, remaining same in magnitude. Okay, this means only sign is changed, magnitude is same. Determine the time t from the beginning of the motion in which the point mass returns to the initial position. Okay, this means we have to determine the whole time from which the point mass started from the initial position and returned to it. Okay, alright, so we see that this is the point O. This is the mass. It starts moving. Starts moving means initial velocity is 0. Because it is written in the question that the mass starts moving, okay, with a constant acceleration a. So initially it is given an acceleration a, then only it starts moving, and at point P, or we can say when time t1 has elapsed, the acceleration changes sign, remaining same in magnitude. So that's what I have written, and it remains same. Okay, this means the particle now goes from O to P, then acceleration changes sign, then it goes from P to Q and stops at Q, and then the reverse acceleration takes it towards O. Okay, so time from P to Q to O, this, let us say this is T2. Alright, and then time from O to P, this is T1. So we have to calculate T1 plus T2. Alright, we have to find this. So how do we do this? And we have to find out, just a second. Yeah, we have to find out the whole time from the beginning. Okay, so we have to find out, basically we have to find out T1 plus T2. Now what do we do? Alright, so we know that this time is T1. Okay, now from P to Q, what happens is, at P it must have acquired a velocity V equal to U plus AT. This is the first equation of motion. When time t has elapsed, T1, this means A T1 would be equal to V at P. U is 0, mind it. So this Vp would be equal to A T1. Now acceleration has reversed. This means we apply the second equation of motion. Sorry, first equation with deceleration. So final velocity would be U minus AT when deceleration occurs. What happens is U was Vp, okay, at P, minus A has because A has changed direction, and T is what T is the time from P to Q. Alright, T is the time from P to Q. This would give 0. Why? Because at Q the particle has stopped. That's why the velocity at Q would be 0. So time from P to Q would be equal to Vp by A. What is Vp? This is A T1. This means this is also T1. So this time is also T1. Now what happens is, again the particle starts from Q and then ends up at O. Now what is the total time? For this, what happens is, it has started from acceleration. This means the initial velocity at Q, when it starts from Q towards O, is 0. Alright. So only acceleration has occurred. Now what is the total distance? You see the total distance, let us say from time taken from Q to O is T, for example. So S we know is ut plus half at square by second equation of motion. U at Q is 0, as I already explained. So this means SQ to O is equal to half A. A was okay, AT square. T I have assumed is total time from Q to O. Okay. Alright. So we have this. Now this QO is all same as OQ. Okay. So what is the distance when particles first started from O and then landed up at Q? This would be, first of all, this would be half AT1 square. This would be OP. Now again particle has decelerated. But since the final velocity is 0, this means again this distance would be half a t1 square only, okay, because time t1 has taken and deceleration has occurred, and since final velocity is 0, so we can assume that this would be the distance. So total distance OQ, what is total distance OQ? This is a t1 square, alright, this is total distance OQ, this would be equal to QO. So we see half a t square equal to a t1 square. We can cancel a, what is t? T is root 2 t1, okay. So what is the total time? Total time is from first it started from O to P, which was t1, then again P to Q, which was t1, then again Q to O, this was t, and what is t? Root 2 t1, alright. So t total, so time total would be t1 times 2 plus root 2, alright. This is the total time taken, okay. This is the answer, alright. Alright, we move on to the third question. Two bodies move in a straight line towards each other at initial velocities v1 and v2, okay. This means these velocities are directed towards each other and with a constant acceleration a1 and 2 directed against these velocities. This means the accelerations are directed opposite, but the velocities are directed towards. What must be the maximum, okay, just you know, be careful on this. This is maximum initial separation between bodies for which they meet during the motion, alright. So this is the situation. You see these are two particles, they are approaching each other, but their accelerations are directed against. This means they are decelerating, okay, but they are eventually approaching with deceleration. Let us suppose the distance between these two particles initially is L, alright. We have to make this maximum first of all, okay. Suppose they meet at this point. For example, this point is A, this is B, and this is C. Suppose they meet at B. So what is the distance covered by this particle? Let us say this is X and this is Y. So what is X? In time T, they will meet, okay. This means X would be V1T minus half A1T square, alright. UT minus half AT square, the second law of motion, okay. What would be Y? Y would be V2T minus half A2T square. Why same T? Because they have reached this point B in time T, okay. So what are the distances X and Y covered in time T? So what would be X plus Y? X plus Y would be L, okay. So X plus Y would be equal to V1 plus V2 whole T minus half A1 plus A2 T square, right. Now when this would be maximum, okay, as I already told you, a function is only maximum in terms of its variable if d square y by dx square is less than 0 and dy by dx is greater than 0, equal to 0. When dy by, for example, y equal to function of x, now I want to find out the value of x, a value of x at which y is maximum. First of all, I'll find out the differentiation of y with respect to x. We will get some value x naught. Now we put this value in this x equal to x naught when d square y by dx square. When by putting this value, if we get less than 0, only then the quantity is maximum, okay. So first of all, we will differentiate L with respect to time because the variable only here is time. So dl by dt would be 0. So this would be v1 plus v2 minus of a1 plus a2 into t equal to 0. I will not teach you differentiation, I have already taught you, okay. So t would be equal to v1 plus v2 upon a1 plus a2. Alright, we have t over here. Now we can put this value in double differential and find out whether that expression is negative or not. You see, this was single differential. Now we again differentiate this expression. v1 plus v2 is gone because it is a constant. Now t is gone, thus we are left with minus of a1 plus a2. So we need not put the value of t as t is not here. So already this value is negative, okay. This means at this value of t, v1 plus v2 upon a1 plus a2, if we put in this expression L, then we get maximum value of L, alright. So just we have to put this value, okay. So what was L? L was v1 plus v2 t minus half a1 plus a2 t square. We just put the value t equal to v1 plus v2 upon a1 plus a2. So what would be L? This would be v1 plus v2 whole square divided by a1 plus a2 minus v1 plus v2 whole square divided by twice of a1 plus a2. So we get L max equal to v1 plus v2 whole square by twice a1 plus a2. You see, this is very familiar expression, because L is distance is always v square by 2a, if you remember. So what, this is the lengthy procedure. What we could have done is that these are the velocities, okay, v1, this was v2, this was v1, this is a1, this is a2. So we could have find out the relative velocity and the relative acceleration, okay. So what we would have done is that the distance of separation would have been reduced to velocity relative square by twice acceleration relative square. So what is velocity relative? This would be v1 plus v2 whole square. What is acceleration relative? This would be twice of a1 plus a2. Not v relative square by twice a relative. So we would have got the same answer, L max, okay. This is my answer. Alright, so let's move on to the next question. It is written the two bodies were thrown simultaneously from the same point, one straight up and the other at an angle theta to the horizontal. Initial velocity of both the bodies is equal to v0, neglecting the air drag. Find the distance between the bodies t equal to 1.7 seconds later, okay. Alright, so this is the figure. This is the point O from which both the bodies are thrown. One body A is thrown vertically up and the other B is thrown at an angle theta. So you see, the other body B will follow a parabolic path, or we can say it will be a projectile, okay. The first body A will go up straight, okay. So now we have to find out the distance t seconds later. For example, if this is the point t seconds later and this is the point of A t seconds later, I have to find out the value of the length of this distance. For example, this is A dash and this is B dash, okay. You see, I cannot, just find it out like this. First of all, you have to see that it is coordinate geometry. So in coordinate geometry, we first find out the coordinates. For example, coordinates of A, let them be x1, y1, coordinates of B be x2, y2. Then the distance, A dash, B dash. Then A dash, B dash will be root x2 minus x1 whole square plus y2 minus y1 whole square, okay. This will be my answer. So I'm going to do the same. For example, for A dash, since the body is thrown vertically up, this is along y-axis and this is x-axis. So body is along y-axis, so I am assuming this x1 to be 0, okay. Since along y-axis the x coordinate is always 0. What will be the y coordinate? You see, y will be the distance ascended upwards, okay. Since it is thrown with a velocity v0, we can use the second equation of motion, which will be y equal to v0 t minus half gt square, as there is a downward acceleration of g, okay. So this will be the distance, okay. Alright, now what will be the coordinates of B? Let us say, B dash actually. Let us say x2. You see, x2 will be the multiplication of horizontal component of velocity with the time. So this would be v0 cos theta times t. So this would be x2 and this would be y2, the vertical distance. What will be y2? We can use the second equation of motion, but the vertical velocity here will be v0 sin theta. Alright, so this would be same. Same we can write, just replace v0 by v0 sin theta. This will be v0 sin theta t minus half gt square. Now you apply this formula A dash B dash. So we get A dash B dash will be equal to x2 minus x1. x1 is 0. So this would be v0 cos theta t whole square plus y2 minus y1. When we do y2 minus y1, this cancels out. Okay. And we are left with v0 t times 1 minus sin theta whole square. Okay. Now we can just solve it. A dash B dash would be equal to, we are taking v0 t out and we have cos square theta plus 1 plus sin square theta minus 2 sin theta. Okay, so a dash b dash will be equal to v naught t. Cos square theta and sin square theta add up to make 1. 1 plus 1 will be 2. So this would be root under 2 times 1 minus sin theta. This is my answer. Okay, how do I check this is correct? You see, if theta is 0, then both the bodies are thrown upwards, and at time, since they are thrown with the same velocity, there will be no distance between them at time t. So when we put theta equal to 0, dash b dash should be 0. So here, if we put theta equal to 0, no. Actually, if you put theta equal to 0, then it should, theta is here 90, yeah. Theta can't be 0, actually 0 would be along horizontal axis, yeah. Theta should be 90 over here. Only then the second body will be thrown upwards. If theta is 0, then I am throwing second body horizontally, alright. So theta should be 90 degrees. So to check whether my answer is correct, I put theta equal to 90 here. So a dash b dash should be equal to 0. And it is, because sin theta is 1, 1 minus 1 will be 0. So this means both the bodies will be thrown upwards and there will be no distance between them at time t. Alright, so this is my answer. Okay. Alright, you see it is written two particles move in a uniform gravitational field with an acceleration g. At initial moment, the particles are located at one point, okay, and move with velocities v1 and v2 horizontally in opposite directions. Okay, find the distance between the particles the moment when their velocity vectors become mutually perpendicular. Alright, so this is the figure. For example, the initial bodies, let's say, are located at A, and their velocity vectors are directed horizontally away from each other. Now it is written that they move in a gravitational field. Okay, gravitational field means either they are going up or going down. I assume that they are going down. Okay, because there is no external force, so the natural motion will be going down. Okay, and this is the coordinate axis I have drawn. This is positive I, this is negative I, this is positive j, and this is negative j. So what happens is, now after a time t, what happens? They begin to fall down. Okay, this would be the trajectory of both the particles. Okay, for example, let us say at point t time, this is the velocity v1 dash of a first particle, and this is the velocity v2 dash of second particle. And if we trace them backwards, these are perpendicular. Okay, so I have to find out this time. What was this time? I have to find out the distance between them. Okay, at this point of time when these velocities vector v1 dash and v2 dash were perpendicular. Okay, now how do I do it? First of all, what is v1 dash and v2 dash we should find out first. You see, they are falling. This means horizontal velocity will not be affected by gravity. Okay, because gravity acts in a vertical direction. So horizontal velocities will be same, v1 and v2. But their vertical velocities will differ. Here the vertical velocity will be gt. Okay, because v equal to u plus at is the first equation of motion. Since body is going down, velocity is down, initial was 0, so this means minus v y equal to minus g into t. So vy equal to gt. This is the magnitude. Okay, so, and here also it will be gt, because the time is same. So what will be v1 dash vector? V1 dash vector will be v1 minus I, because minus I is along the backward direction, so v1 is directed along minus I. Okay, and plus gt times minus j, as gravity is along minus j. Okay, I have assumed the axes. v2 dash would be v2 times positive I plus gt times negative j. Okay, so when these two vectors will be perpendicular, you see, as I discussed in my previous videos, if you have not seen them, please go and watch them, because they deal with vectors. So when two vectors are perpendicular, only when their dot product is 0. Okay. So when v1 dash and v2 dash will be perpendicular, when v1 dash dot v2 dash will be 0. Alright. Because dot product, what is dot product? A dot b equal to ab cos theta. When a dot b is 0, then that means cos theta is 0 because a and b can't be 0. Okay. So theta will be pi by 2. Alright. So now we do the dot product of these two vectors. We have minus v1i minus gtj dot v2i minus gtj. This should be 0. I dot I is 1, so this means this is minus v1 v2. Okay, I dot j 0, j dot I is 0, and plus g square t square, j dot j is 1. Okay, and now from here we have t equal to root under v1 v2 by g, and t can only be positive because it is time is a positive quantity. Okay, alright, so we have t equal to under root v1 v2 by g. Now we have to find out the distance between them at time t. You see, this distance, this much distance will be v1t and this much distance will be v2t. Okay, since horizontal components are unchanged, so v1t will be the horizontal distance traveled by first particle, v2t will be the horizontal distance traveled by the second particle. We add it and we get the total distance. So total distance s would be equal to v1 plus v2 times t. What is t? T is root under v1 v2 by g. Okay, this is my answer. This is my answer. Okay. Alright, moving on, we have a car starts moving rectilinearly first with acceleration w. Okay, this means it starts moving. This means the initial velocity is 0. It has directly accelerated. Then uniformly. This means after acceleration, after point of time, then it moves uniformly, means acceleration is 0. And then finally decelerating. At the same rate w comes to a stop. The total time of motion is tau. The average velocity is given. So we have to find out how long the car moves uniformly. Okay, we don't have to find out the whole time. We only have to find out how long the car moves uniformly. Alright, so this is the figure. First of all, I want to tell you, in any problem of physics, be sure to draw the figure first. Okay, because figure helps you a lot in understanding the problem. So a car starts from A and now it directly accelerates. So the acceleration is w over here. At point B, it starts moving uniformly, so there is no acceleration. Okay, from B to C, and now it decelerates after C. This means the deceleration is w. I have drawn the vector, so no need of sign. Okay. Alright, so this is the case. Now it is given that average velocity is v and total time is tau. Alright, so total time is given. We have to find out the time it moves uniformly, means tbc. Alright, this means, first of all, what is total time? T A to B, then T B to C, and then T C to D. This will be the total time tau. Okay. What is the average velocity? Average velocity is total displacement upon total time, right? What is the total displacement? It is AB plus BC plus CD upon total time is tau. Okay. So we have established this. Okay. Now, since it starts from acceleration, this means the initial velocity at A is 0. This means what is the velocity at B? U plus AT it is, right? U is 0. This means W times time taken from A to B. Okay. Alright. Now, we have to calculate time taken from B to C. What is the time taken from B to C? You see, again we can apply, since it is moving uniformly, so the distance of BC would be equal to velocity of B times time taken from B to C. Why? Because here the acceleration stops, so the final velocity reached at B will continue till C. Okay, so the distance covered would be velocity of B times time taken from B to C. Alright, And now what about C? The deceleration happens and it stops at D, right? This means the initial velocity was what? Vb, because the Vb has continued from B to C. Minus W times time taken from C to D, this would be 0. Okay. So time taken from C to D is velocity of B by W. Alright. Now what is the total displacement? Total displacement will be, first of all, SAB. SAB would be equal to half W time taken from A to B whole square. Okay. And SBC would be equal to velocity of B times time taken from B to C. And SCD would be equal to half W time taken from C to D square. Why? Because final velocity here is 0. So V square minus U square is 2as. Alright. This means V square minus U square is 2as. V is 0. This means minus, what was U? U was VB. And what was A? A is deceleration, W and S. So what is VB? VB is W squared time taken from A to B whole square divided by 2W. Half W TAB square. Now why TAB and why this is TCT? You see, I will tell you why. Here the final velocity at D is 0. What was initial velocity at C? Initial velocity at C was VB. So we use the first equation of motion, V equal to U plus AT. Here V is 0. This is deceleration. So what is U? What was U? U was VB minus W times time taken from C to D. This would be 0. Okay. What is velocity of B? Equal to W times time of AB. This would be equal to W times time of CD, and W would cancel out. The time taken from AB would be equal to time taken from C to D. Okay. Alright. Let us assume time taken from A to B equal to time taken from C to D equal to T. Alright. So what is the time taken from B to C now? Let me do it over here. This was the original figure. This is A, this is B, this is C, this is D. Okay, I have established 2-3 things. One, the velocity at B is VB and it continues throughout from B to C. And here velocity is 0. Here there is acceleration, here there is deceleration. I have also established that time taken from A to B equal to time taken from C to D. I have also established this. Now, let us say this is TBC. So what is tau? Tau is 2T plus TBC. What is TBC now? Tau minus 2T. Okay. Alright. What was the distance traveled now? Distance traveled, total distance would be equal to half WT square for A to B. Then for B to C, this would be VB times TBC. And then plus half WT square, as I have already told you. Okay. So this would be WT square plus VB times time taken from B to C. Alright. Now what? Now you see this is S. Okay. This total distance is also the total displacement because the direction is only one direction. The particle is not moved. Since direction has not changed, so displacement becomes distance. So we can equate it with displacement. So we have S equal to V times tau. Average velocity time, total time. Okay. This would be equal to WT square plus VB times TBC. Okay. Now just we can substitute this. We can substitute T square and we can bring it here. What is VB? VB was, from here we can say VB was WT. Alright. VB is WT. So we have WT square plus WT times time taken from B to C. Okay, we can, this is V tau. So now we have two things. Okay, we have V tau equal to WT plus WT TBC. This was, I think, this was WT square, right? And this was half wt square plus again half wt square. So this would be wt square. Wt times TBC, this would be V into tau. And we have tau equal to 2t plus TBC. Now how do we solve this? We have to calculate this, okay? But t is also not known, na? So we can substitute this. What we do is, we take t over here and we have t equal to tau minus time BC divided by 2 from this equation. So we have tau minus time BC by 4 whole square plus w tau minus time BC by 2 into, this is one bracket, into time BC, okay. So this would be average velocity times whole time would be equal to w tau square by 4 plus w time BC square by 4 minus w tau time BC by 2. This is one expression, okay. Plus we solve this now. So we have w tau time BC by 2, okay, minus w time BC whole square by 2, right? So this cancels out, okay. What are we left with? We are left with w time BC square by 4 minus w time BC square by 2. This would give us w tau square by 4, and this would be 4 will be the LCM, 1 minus 2. This would be minus 1, right? So this would be minus w time BC square by 4, okay. Now just this is the equation, okay. We have to calculate time BC. So we multiply both the sides with 4. We have 4 Vt and we divide by w. So we have by w equal to tau square minus time BC square, okay. Yeah, this is the equation, okay. So 4 V tau by w equal to tau square minus time BC square. So what is time BC square? This would be tau square minus 4 V tau by w. So time BC is under root time square minus 4 V tau by w. This is the answer, okay. This is my answer. This is average velocity V. This is tau. This is w. Alright, this is my answer.